Welcome back. We will now discuss the last part or last topic for our pre-final lessons. Okay? And this is the register. So, yung learning outcome natin is number 1, define register circuit. And 2, know the different types of register circuit and know the shift register counters. No? So this is the most important part of the CPU, no? The central processing unit sa ating computer. No? A register is a sequential circuit with n plus 1 as the, not counting the clock, inputs as inputs and then n output. No? To each of the outputs corresponds an input. And first n inputs will be called x0 to xn minus 1, and the last input will be called the load, and the n outputs will be called the y0 to yn minus 1. No? So, ang tatandaan nyo is sa register, there is a corresponding outputs for an input. Okay? So, when the load is 0 or LD is 0, the outputs are unaffected by any clock transition. No? When the ID input is 1, the X inputs are stored in the register at the next clock transition. Okay, so ang ating register ay affected by clock transition. Bakit? Sa loob kasi ng register may mga flip-flops. Okay, makikita natin mamaya yun. So, dependent sila sa yung pagtaas, pagbaba ng clock pulse. Okay? So, to explain the previous paragraph, we can explain this behavior more formally with the state table. As an example, let us take the register with n value of 4. No? So, meron tayong input 4. The left side of the state table contains 9 columns labeled x0 to x3 and load, and then y0 to y3. This means that the state table has 512 rows. And then, we will therefore abbreviate it. Ibig sabihin ay hindi dito nilagay lahat. No? Hindi pinakita yung kasi mahaba yan, no? 512 rows. No? So, kaya sabi rito, therefore, we abbreviate it. No? Okay, so, yung pag daw si load ay 0, makikita natin si left and right magkapareho sa output. No? Yung y is output, di ba? Ito, output, output. So, pag naman 1 siya, makikita nyo yung x, which is the input, ay pareho dun sa right side na output. Okay? So, yun ang difference ng value ng load ay 0 at ang value ng load ay 1. Okay? So, register play an important role in computers. Some of them are visible to the programmer and are used to hold variable values for later use. Some of them are hidden. Okay? To the programmer and are used to hold values that are internal to the central processing unit but nevertheless important. So may mga register na ginagamit, pwedeng gamitin ng mga programmer, no, directly, but there are registers na nakatago dahil yung processing unit yung gumagamit nun, no? So hindi available sa mga programmer yon. Shift registers are a type of sequential logic circuit mainly for storage of digital data. So kapag meron tayong mga values na kailangang i-store, okay, nilalagay natin yun sa shift register, no? So they are group of flip-flops connected in a chain so that the output from one flip-flop becomes the input of the next flip-flop. So naka-serial siya, no? And then all the flip-flops are driven by a common clock and all are reset simultaneously. Okay? So sabay-sabay silang nire-reset, no? So walang naiiwan. Kung 0 ang isa, 0 dapat lahat. Okay? So, tsaka may isa lang yung clock na kanilang sinusundan. No? So, another type is the serial out, serial in, serial out shift register. No? A basic 4-digit shift register can be constructed using 4D flip-flops. Okay, so ito yung modified version ng SR na flip-flops, diba? So, mas stable to, no? So, yung stable version. So, during each clock pulse, 1 bit is transmitted from left to right. So, yun ang tatandaan nyo. So, from left to right, okay, tinatransmit nila yung data. Okay? Pero yon is tinatransmit nila kasabay ng clock pulse. Kapag nag-clock pulse, ibig sabihin, pag tumaas, then, ililipat, mag-shift sila ng, kaya ang tawag yun ay shift registers, no? Siniship nila yung mga data ang nakaload sa kanila sa bawat flip-flops na to. So, another clock pulse uli, shift uli sila, another clock, shift uli sila. Okay? So that's how they transmit information from flip-flops to flip-flops or register to registers. In order to get the data out of the register, they must be shifted out serially. Kaya yan ay serial in, serial out, from left to right. Yan. Okay? Parang line, no? Naka-fall in line yung mga data. Sinishift nila. Next. Yan. Ito yung representation ng serial, no? Yan, may mga sunod-sunod na or flip-flop connected sequentially. Ito yung read-write control natin. Ito yung input data, no? Yan. Next type is serial in, parallel out. Shift registers for this kind of register database are entered serial in the same manner as discussed in the last section, but the difference is that they are taken out parallel, no? Parallelly. Okay? Or in parallel fashion. So ito yung output natin. Pag sinabing parallel, simultaneous yung paglabas nila. Okay? So ito yung serial in nila. Pumapasok ang data serially. But pag kukunin na ng program or ng applications, they are shifted out parallelly, no? In a parallel fashion. Ibig sabihin sabay-sabay. Yun, no? Yun, sabay-sabay silang lumalabas. Ito yung complete, no? Complete schematic diagram. Next type is parallel in, parallel out. Okay, so obviously, okay, we have parallel in, ito yon, in, and then parallel out. Okay, parallel in, parallel out. So sabay-sabay pumapasok, sabay-sabay din lumalabas. Bidirectional shift register naman, pag sinabing bidirectional, ay the bidirectional reversible shift register one in which the data can be shifted either left or right. So yung shift register kasi na normal na from left to right lang siya. Pero pag bidirectional, can shift, no, from left to right or from right to left. Okay? Yun lang. Ito yung schematic diagram ng bidirectional, no? So makikita nyo maraming coming out from the left, coming out from the right. Shift register counters, we have two types. We have ring counter and Johnson counter. And the registers are classified as counters because they exhibit a specified sequence of states. So, ibig sabihin ng sequence states ay nagsishift siya ng state every now and then, no? So, nire-record niya yung mga pagbabago niya, no? So, sa ring counter is basically circulating shift register in which the output of the most significant stage is fed up to the input of the least significant stage. So, ito lang yung difference ng ring counter sa Johnson counter, no? Dito, yung output daw, yung output natin, ito output, shifted back to the input. Ito, yan, pabalik doon, no? Ito kasi yung output, yan, pabalik doon. But sa Johnson, okay, Johnson counters, yan, you can see na Johnson counters are variation of standard ring counters with inverted output of the last stage fed back to the input of the first stage. Yan. Kita nyo to, ito output, yan, ini-input niya ulit dun sa first stage. Okay? So, mas mabilis to si Johnson counters, mas advanced siya compared to dun sa standard ring counters. Okay? At mas efficient din, no? Kasi sa standard ring counter, ito lang yung gamit niya na column, no? Yan, 16 states lang ang kanyang gamit. While si Johnson is naka mode 2N, ibig sabihin twice nung standard counter yan, twice, di ba? So makita nyo 7, okay? Yung kanyang column or yung kanyang rows, yan. So, mas marami siyang state na pwedeng i-analyze. Yung counters, a sequential circuit that goes to a prescribed sequence of states upon the application of input pulses is called a counter, no? Siya ay sequential circuit, okay? Which prescribe a sequence of states. So, ibig sabihin, nire-record yung mga pagbabago ng state niya depende sa input na pulse, no, doon sa clock pulse, no. So the input pulse is called the count pulse may be clock pulses, no? In a counter, the sequence of states may follow binary count or any other sequence of states. Counters are found in almost all equipment containing digital logic. They are used for counting the number of occurrences of an event and are useful for generating timing sequences to control operations in a digital system. The counter is a sequential circuit with zero inputs and outputs. Yan, tatandaan nyo, wala siyang inputs other than the output ng ibang parts, no? And outputs pwedeng marami, ibig sabihin thus the value after the clock transition depends only on old values of the outputs, no? So yun lang kanyang input, old values of the outputs, and the outputs are interpreted as sequence of binary digits. So ito yung example, no, ng isang counter. Okay, ito yung tinatawag na state table, 4 column, yan, 16 rows, no? So makikita nyo yung mga ones, yan, naka-wrap around, no? So explain natin dito yun, no? As you can see, the right hand side table is always 1 plus the value of the left hand side of the table, except for the last line where the value is 0 for all outputs. We say the counter wraps around, okay? Binibilang niya kasi yung certain occurrences or change of states, no? Depende dun sa kanyang sinusundan na clock pulse. Counters with some variations play important part role in computers. Some of them are visible to the programmer, such as program counter or PC. Some of them are hidden to the programmer and are used to hold values that are internal to the central processing unit but nevertheless important. Yan, counters ginagamit yan ng mga application, no, para sa mga trial version, no? So siya yung nagde-determine kung ilang beses mo na in-install yung application na yon, yung trial version ng kanilang software, no? Yan, para hindi ma-hack. Yan, ilalagyan nila ng mga counter yung na-register. I mean, yung information nila, yung serial number at mga control numbers nila, nilalagay nila sa isang counter. Design of counters, yan. So, yan, no? So, ganyan ang representation ng isang counter. A counter is first described by state diagram which shows the sequence steps through the counter advances when it is clocked. So, kapag habang nare-receive niya yung pulse, yung clock pulses, yan, nag-a-advance siya, no? Yan, from 0 to 0, 1, then, yan, para siyang seconds sa relo, no? Every second gumagalaw, bumabagsak na gano'n, paikot. Okay? Yan. The circuit has no inputs other than the clock pulse and no outputs other than its internal state. Outputs are taken off each flip-flop in the counter. Okay, the next state of the counter depends on its present state, and the state transition occurs every time the clock pulse occurs. Okay, until na bumalik siya sa 0. Okay, so that's it for our register topic. So you can have or take your pre-final quiz 2. Okay.